Hi everyone, good morning. Today we'll talk about system design for a stockbroker like Zerodha or Robinhood. Let's first go through the functional requirements. First, we should be able to buy or sell stocks. We should be able to view the stock price changes with very low latency, and we need add support for portfolio of stocks that the user has, and handle watch list for of stocks for the user, and also support wallet, basically funds for a user. Moving on to the non-functional requirements, let's assume there are around 100 million total users, and around 10% of them, that is 10 million daily active users, uh, and around 5,000 total stocks. And on an average, a user trades 10 stocks per day. And the average number of stocks in a portfolio for a user is around, let's assume it's around 20, and average stocks in a user's watch list is around, say, 100. Let's assume 1 million of them in a day are day traders. That is 10% of the daily active users. Around 1 million are daily traders or day traders. Moving on, uh, from these metrics, let's build the system. Now, the total operations for buy or sell per day will be 10 million, that is a daily active users, into say 10 stocks per day, that is 100 million operations per day. Considering the stock trading price is between 9:30 a.m. and 3:30 p.m., that is around 6 hours. The operations per second is around 5,000, and the peak ops, let's assume, is two times this, that will be 10,000 is a peak ops. Let's consider the APIs that might be offered by a stock exchange. Uh, on API will be the get latest price for all the stocks. So if there are 5,000 stocks, the total data size might be around 1 MB. Then get stock details per stock. Let's assume per stock might be around 100 bytes of data, and slash trade, which is for buy or sell. And since there will be multiple stockbrokers connecting to the exchange will also have a rate limit on the number of ops per stockbroker. Let's consider the for the latest price for all stocks will be around 10 per second on the exchange side, and for get stock details will be around 100 per second per stockbroker, and for trade it will be around 20,000 per second, that is two times the peak, that is 10K peak ops for a stockbroker. Now, a day trader is someone who's online throughout the day and uh, monitoring the stocks, and a regular trader is someone who, let's assume, logs in maybe maximum 5 times a day, or on an average 2 to 3 times a day, to check the stock details. With these details in mind, let's go ahead. Now, a user will have to log into a website or mobile, uh, and from the website or mobile, the request will be sent to a load balancer. The load balancer will distribute the request to multiple API servers, which will in turn handle send the request to the respective services for the request. Now, moving on to the service, we have a user profile service for specific to the user profile, which will be also talking to the fund management service, which will get the fund details for a user, and the fund details will be stored in a fund DB. This will be a relational DB, say MySQL, because with respect to money, consistency and partition tolerance is more important. So we'll have a relational DB here. And for moving on to the next service, the order service takes care of the buy or sell of a stock for a user. It will talk to the validator service to check if there are enough funds for available for the user to perform the trade, and it also can perform multiple other validations. And then it will store the metadata in the orders DB. This will also be, say, a MySQL or relational DB, but because here as well we'll need consistency and partition tolerance. Availability is okay. The order service will talk to an exchange coordinator service, which is basically a service that takes care of requests being sent to the exchange. The order service will send the buy or sell trade request to the exchange coordinator service, and the exchange coordinator service in turn can send server-side events to the order service to handle the um, to update the uh, status of the order. The order can be either a limit order. Let's assume it can be either limit order or normal order. So if it is a limit order, it will send the order to the exchange, and the exchange will make sure when it has to be triggered. And once triggered, the order will be order status will be sent back to the exchange coordinator service, and the exchange coordinator service will send it to the order service. Now, the protocol between the exchange coordinator service and exchange will be a fast protocol. That is, it is a protocol that is used for financial transactions, which has high throughput and low latency. And once the order details are retrieved by the order service, the metadata will be updated to the orders DB. Right? Now, one other point that I wanted to mention with respect to fund management. Fund management will also take care, fund management service will also take care of, say, getting, connecting with apps like PhonePe or bank accounts to update the fund details. Or once the money is transferred to, say, Zerodha will send a request to the fund management saying the amount that has to be added for the user, for a specific user, and that will get updated to the fund DB. Okay, now moving on to the portfolio service. Uh, Before moving on to the portfolio service, let's talk about the ticker service. The ticker service is basically taking care of the stock price updates. So it'll, for a portfolio service or a watch list service, it'll get the portfolio service or the watch list service will send the request to the ticker service asking for the price update for a specific set of stocks for a user, and the ticker service will retrieve the data for those stock values and send it to the portfolio service. And the portfolio service will store the data in the portfolio DB and portfolio cache. So, um, considering that there are around 5,000 stocks, and say 20 bytes of data is used per stock, so there will be around 100 MB of 100 KB of data that will be needed. So cache should be sufficient to store the stock price. Now, the stock price will be updated can be either updated by the exchange coordinator service directly to the ticker cache, or the exchange coordinator service can send SSC or server sent events to the ticker service, and the ticker service can take care of updating the ticker cache. And with respect to the portfolio, considering that there are 1 million day traders, so the day traders, most of their data will be in the portfolio cache because they need low latency. But a regular trader the data can still be stored in the portfolio DB to make best use of the um, resources. So, considering there are 1 million day traders, 1 million into, say, uh, 20 bytes per stock, and they have around 20 stocks, so it will be 400 bytes in total. Let's assume it's 500 bytes. So 500 bytes per user, and into 1 million, it will be 500 million or 0.5 GB of data. And if there are uh, so 0.5 GB will minimum be stored in the cache. Now for 10 million daily users, it will be around 5 GB of data in cache. The cache we can use, say, memcache should be enough because it will just be a key value pair for a particular user. What are the stocks, right? And in the DB, it will be around 50 GB of data because there are around 100 million users. So for 100 million users into 500 bytes, it will be around 50 GB of data. Uh, so the portfolio DB can be a NoSQL DB. Cassandra should be good enough for the portfolio DB. We don't need a document DB, so Cassandra DB should be enough. Similar with the watch list service, the watch list cache will be storing most of the day trader users, and only for a regular user, whenever they log in, the first time the data can be retrieved from the watchlist DB, and the data can be stored in the cache with a DTL of say 1 hour for the regular users. Considering there are 10 million regular users and 100 stocks and 20 bytes per stock. So 20 bytes into 100 is 2000 bytes for a user. And there are around 2000 bytes per user, and there'll be around, say, 10 million daily users. So 2000 bytes into 10 million is like 2 GB of data will be in the cache, and for 100 million users, there'll be around 20 GB of data in the cache. I think I got it right. Let me check the calculation. So watch list will have 100 stocks, and per stock say 20 bytes. So 2000 bytes per user, and there are around 10 million. So 20 GB of data will be in the cache, and 200 GB of data for 100 million in the data store. So 20 GB in the cache and 200 GB in the DB for watch list. Uh, so considering that from the exchange we can read 10 times per second for the stocks, the data can be updated in the ticker cache 10 times per second, and say, and the ticker service can or the portfolio service can request for the data every 1 second once to update the portfolio cache. That should be good enough. And the API servers, they can read the data, say, every 30-second once to update the uh, value for the user. So this will ensure that the user gets uh, quite frequently. And let's say if for the day traders, it needs to be faster. So maybe for the day traders, it can uh, request the portfolio service, or the API service can be made a little faster, maybe every 10 seconds instead of every 30 seconds. It could be updated every 10 seconds for a day trader, and for a regular user, it could be updated every 30 seconds. This should cover most of the cases. So the main advantage of doing this, that is storing it in a portfolio cache, is that there will be low latency instead of getting it from the exchange every time. And we are ensuring low latency by making sure that we don't get it from the exchange every time, and also that we are not always updating all the stock entries. That is 1 MB of data. This will be few KBs, few bytes, say 500 bytes of data per user. That will be uh, needed. So the latency is very, very low to read from the cache. And we are making good use of all the DBs as well. I think I've covered most of the points. If there is anything else, please do let me know. Okay, and all the other connections will be WebSocket connection, just an FYI. Only these two will be server sent events, and this one will be a fast protocol. I think that is good enough. Okay, thank you everyone. Thanks for your time.